and I could be standing few meters away, and this would not matter, because I could be just the calculated position would be just as noisy as in both cases. I tried to play a little bit with time settings and strength, and all of those were, in all cases, I was getting the similar results. Okay, this is, I believe, if I remember, this is the person who attended many lectures. So you already seen data from this person. As you can see, there are more or less constant positions, but they are not very good ones. I even tried to kind of use fast Fourier transform to kind of make this data more smooth, but it was not very precise then. So there is, I'm afraid there is no good solution. So during the last hope, they have two different floors, which were which were far away, and it means that they have more easy situation. But I do not want to talk too much about the position. So now, for something completely different, the large or the task for you. What can be said about this sequence? Some ideas? Excuse me? Okay, not to hold you too much. This person was staying mostly in the same place, in these green areas, and for 1 hour or so in these blue readers, in the range of these blue readers, and during the last talk, he or she, or I could see, he was in the cell ice. So he was attending the last lecture. This is summary what I said. It was near the Sputnik station, Sputnik table. During that day, when blue stations were active, there was presentation of the Sputnik data. I believe it was the Miloš Mariak, the creator of the Sputnik project. When I asked him, he neither confirmed nor denied that it was him, but he said I could use this as the example. By the way, as I said, D002 was just below the Sputnik tables, and it was in the different level, and it was also able to detect this. So this is Miloš. So summary of positions. We do not always need the exact positions, but having a rough idea where someone is helps. But for the Sputnik system, we do not need this. Okay, I'm afraid I'm getting out of time, so I will just talk about entropy, which I believe is very interesting. Entropy is the measure of how much data is random or how much it is unpredictable. It was proposed by Shannon. It is calculated like that, so we have probability of getting value, some of those probabilities multiplied by their logarithms. Minus comes because probabilities are in range of 0 to 1. So if we get logarithms from this, we would get negative values. So we want to have positive entropy. I used rather sophisticated query to calculate this entropy. I got a short period of time, divided it into few seconds sub-periods, get all stations that were seen, calculate maximum strength of the signals from those sub-periods, calculate how many different combinations of those are in the system, then treated a number of those combinations as base, divided each number by this base, and got the entropy. So here are examples of some. This is entropy, global entropy of all subjects. Low entropy means basically someone was not moving much. High entropy means that someone was moving very rapidly and very much during the combust. So here are the entropies of people that I already talked to you about. So this was angel responsible for tickets. When he was in heaven, we have low entropy, which means that he was in one place and not moving very much. Oh, by the way, entropy almost never goes to 0. If it goes to 0 for long periods of time, it probably means that someone just left the tag sitting and was not wearing it. Because of the tags, of the way I'm calculating entropy, there is problem with, there is almost impossible for a living person to have 0 entropy when he or she is wearing tag. This is angel sitting in heaven. As you can see, he or she was there in the one place, except for the one day I was talking to you about, when it is very large entropy. Here is someone who attended many lectures. As you can see, during the most time it was low entropy, sitting in one place, except when it went to high entropy, when he or she was going to the another room or to get some food or things like that. Because as you can see, or as you probably wonder why, during the last day there was slightly larger entropy than during the previous days. Because we do not have any social data about the subjects, because we do not know who it was, whether it was man or woman, what he or she was finding interesting, we do not know what caused this behavior. Maybe it was just that his or her friends came on the last day and they were just more socializing and less going to the lectures. So, okay, I think I will leave the AMD. AMD was just intended to get the social data from people, so people were able to log into the web page and give their nicks and handles and things like that, and then it was able to people were able to see not their numbers but their nicks on the. Okay, one more.